For ellipses, we're going to just focus on the basics. We're not going to get too in-depth here. With a little bit of time left that we have in the school year, we just need to cover the basic idea of how the major parts of an ellipse, how to graph it, how to write the equation, and we probably won't go too far in depth. So you can see we have a lot of bull words here at the beginning, but the main thing that I want you to be aware of is how ellipse is defined. If we look at the two focal points in an ellipse, if we were to draw two segments, one from each ellipse, to a point on the edge of the ellipse, those two segments added together will always be the same number. So no matter where I drag my p-value, so if I have a p-value over here, these will be the same length when you add them together as they would be anywhere on the outside ellipse. So that constant value is what defines the ellipse. Now, we see this as being a little different than a circle, because a circle had one focal point, which was the center point, so it was only defined by one segment, and that segment was the radius. So we have a little different scenario here. Now, since we know how to define an ellipse, we thus create a handful of parts when we do create the ellipse. So let's take a look at some of the parts of an ellipse. First and foremost, when you create an ellipse, it'll either be long on a horizontal axis or it'll be long on a vertical axis. And so what we're looking at here is a picture of a horizontal and then also a picture of a vertical version of each of those. Now, if you were to basically draw a line through your focal points or your foci, you would be going along what is called the major axis, and that major axis is going to connect what we call the vertices. And so when we draw a line through the foci from one edge of the ellipse to the other, you can see that we're going to get vertices on the edges, and that is going to be our major axis, since it's going to be the longest part of the particular ellipse. Now, whenever you have an ellipse, one is going to be longer than the other. It's going to create this oval shape. So whenever you have the other axis from one point to the other, these are called co-vertices, and this is called your minor axis. Now, one of the things that you want to be aware of is that the vertices are always labeled with an A value, and the co-vertices are always labeled with a B value. And so that's extremely important when you look at an equation of an ellipse. You'll know whether it's horizontal or vertical based off of the larger value. So the A value will always be larger. So A is always the largest value. Now, if we take a look at the equation of an ellipse, you can see we have x squared over a squared plus y squared over b squared equals to 1. This is similar in a circle in a couple ways and different in a couple ways. First of all, for this particular example, if we have x squared plus y squared, we're saying that the center of our ellipse, which is between our two focal points and between our vertices, if it's x squared and y squared, we're talking about a center point at 0, 0. Now, notice in this case, instead of just having x squared and y squared, we actually have them in fractional form, and the whole thing is equal to 1. In a circle, we had it equal to some number which represented the radius squared, but here we're always going to be equaling to 1, or at least that's the form that we're going to be trying to put it into. Now, if we know that the A value is always representing our vertices and it's always representing our largest value, it's very easy to tell which axis is the major axis. So you can see in this first one, we have a horizontal major axis. The A value is directly underneath the X. So that means that the major axis must run along the X axis. If you look at the one over here that says vertical, the A value or A squared value is underneath the Y, and so in this case the major axis is running along the y-axis, and so it connects the vertices. And keep in mind that the major axis always connects the vertices that are represented by the a value. That's going to make this chart right here extremely important, since it has all of the major parts of the ellipse. And you can see we have the equation, the major axis is either horizontal or vertical, the vertices are always a's, and the co-vertices are always b's. Now, depending on whether it's horizontal or vertical, that's going to tell you whether the a value is x or y, or whether the b value is x or y. So very important for you to remember. Now, we probably won't get into too much detail about the foci, but there is a simple way to determine what the foci is in this part. The foci is represented by the value c, and you can always figure it out based off the a's and the b's, and you can see that c squared equals a squared minus b squared. Very similar to Pythagorean theorem, but not quite the same. So these are some extremely important parts of ellipses. Keep in mind also that the ellipse can be represented, the center point can be represented by h and k as well, which in this case is just simply 0, 0. So make yourself familiar with all these parts. It is important that you know how an ellipse is defined by its two segments being constant. You need to know the vertices, the co-vertices, the major axis, the minor axis. You need to know the equations. So this chart, this box right here, is going to be extremely helpful in remembering those sorts of things. So take some time to put those parts to memory.